Okay. So hope you all had a wonderful weekend and a good Monday. So today we are going to look at the second algorithm that we can use for clustering, and that is the hierarchical clustering. And just like the name suggests, so this model creates hierarchies. And from Seaborn, we have the heat map and we also have the hierarchical plot. And for the hierarchical plot, we usually have things like those things that look like trees, and those trees define the hierarchy. So when we talk of hierarchical clustering, so it is a type of clustering algorithm that groups similar data points into groups or clusters. So it is based on a tree-like structure called a dendrogram, which shows the hierarchical relationship between the clusters. So if we go back to the notebook that we used for wine clustering, and if we scroll up here to this part where we created a hierarchy, a cluster map. So you see we have these kind of tree-like structures that are over here. So for example, if I only focus on this part, so this is what we call a dendrogram. Okay. And for this dendrogram, we have these features that are starting from down here and then coming up. So we have feature 1, feature 2, feature 3, feature 4, feature 5, feature 6, feature 7, feature 8. So maybe let's say till feature 10, which are grouped together to come up with a smaller group of features. So for example, if we were to place a line here, then it means we would have three distinct features. So we will have feature number 1, we will have feature number 2, and then we will have feature number 3. So these are the three distinct features that we will have created from maybe let's say 11 features that we have in the data set. So this is how a dendrogram looks like. So it's a tree-like structure whereby we have down here our features, and then up here we have the created groups, so the smaller groups that we will have created from all these features. So there are two ways of creating these dendrogram. And first of all, you can either start from the bottom going up, or you can start from the top going down. So you can start with this big group, maybe let's say group of 2. Then that group of 2, you split it to other groups till you have all the features that you have in your data. And that is what we call the divisive, okay? Divisive method, where this method starts with all data points in one cluster and iteratively divides them into smaller clusters. So this is what we have. So we start with one bigger cluster and then repeatedly we start creating other smaller clusters. Then again, we have the agglomerative method. And this method starts with the individual data points as separate clusters and iteratively merges them into larger clusters. So here we can think of these features as single data points. And what we are doing is we are merging them into smaller clusters that we can manage. So those are the two ways in which we can create hierarchical clustering methods. Another thing you need to note is when creating the hierarchical clustering model, so you don't have to specify the number of clusters you want in your data set, okay? So what you do is you'll just have to specify the points in which you want your dendrogram to be cut off, and those will be your groups in your data. So we can check an example, and what I'll do is we'll use what we've been using in class, and that is the k-means notebook. So I want you to open the k-means notebook, and then we will use the same data that we used up here. And what we'll do is we will just do a continuation down here. So I'll delete the make blobs part, but you don't have to delete that on your side. And then I'll add the header here. For hierarchical clustering. Then before that, I'll have to run all cells. So I'll clear all outputs and then I'll click on run all. So I'll give you 3 minutes to set up your notebooks and then we can proceed. So at 8:13, we continue on with the class. Okay, so let's proceed. So what we'll do here first is we will check our data set. So if we really do have our data set copy, and that should be the iris copy. Then I'll type in dot head. So we have our iris copy data set. So before we proceed on, the first thing I'll want us to do is I will want us to drop the created groups. So this is from the k-means part. So here I'll drop the created groups column from the k-means model. Okay, so we've done that already. So the next thing we are going to do is we are going to import the hierarchical clustering algorithm. And the model that we are going to feed first is the agglomerative clustering model. So when it comes to hierarchical clustering, so the agglomerative model and the divisive model will at least give you similar scores, because at the end you're going to get like similar results. So after importing the model, we are going to instantiate the model, and I'm going to say something like hierarchical cluster should be equal to agglomerative clustering. And as I mentioned earlier, you don't have to specify the number of clusters here. So you can leave it as it is, because here in the notes, you can see when you are fitting the model, you can specify the clusters. But an advantage of using hierarchical clustering model is you don't have to specify the number of clusters. So I'll leave it at that. Then I'm going to fit the algorithm. So we are going to have hierarchical class dot fit. Then we are going to get the iris copy. And then we don't have to extract the labels. So this is what we are going to have for now. So 3 minutes, you copy this and then we can proceed. So after we've done this, what we are going to do next is we are going to plot our dendrogram to see how these splits have been made. So after we've seen how the splits have been made, it's when we can maybe now come up with a decision and say that we need these number of clusters. So for example, 3 clusters or 5 clusters, so something like that. So at 8:20, we will proceed on and plot the dendrogram. So another thing you can do to copy this code first is you can be using what is here in the notes part. So you just copy what is here and then you just go ahead and customize the things that have changed in the code. Okay, so we can proceed. So I'm going to do the plot. So here we are going to plot the dendrogram. So first of all, we have to make some importations. So here we are going to use the SciPy library. And the SciPy library is a scientific computation package for Python, and it's based on NumPy. And the reason as to why we're importing SciPy here is because we have to create something that is called the linkage matrix. So if we go back to our notes, you can see in these, so I can search. So we have the linkage path. So there is a place where the linkage has been explained. So it should be down here. So the linkage matrix has a size of n minus 1, where n is the number of features that you have in your data set. So you minus those number of features that you have in your data set by 1 and multiply by 4. Okay. So here you can see where n is the number of data points. So the first two columns of the linkage matrix represent the two clusters that are merged on that row. And the last two columns represent the linkage criterion value and the number of original observations in the new cluster. So you can go through these notes that I've created here and try and understand it better. And also you can try do more research on this to understand how it works. So let's create our plot. So after that, what we do is we create our linkage matrix. So we have our linkage matrix. So at times we call it Z, as you can see here. We have the Z, and we pass in the linkage function, which we've imported from SciPy, and then we pass in our data set. Then method, we specify word. So if we come back here to our notes, we have the different methods. So the word method minimizes the variance of the distances in the linkage. Then we have the single method, which minimizes the distance between all data points of the two clusters. We have the complete method, which maximizes the distance between all data points in the two clusters. And lastly, we have the average. So it takes the average of the distance between all data points of the two clusters. So let's proceed on. So after we've created our linkage matrix, we plot our dendrogram. So we type in dendrogram, then we pass in our linkage matrix variable that we've created up here. And then we can run that. So here you can see we have our dendrogram. So this is how your dendrogram should look like. Yeah, so you can copy this code in the next 5 minutes and see if you're going to get your results. So I think 5 minutes should be enough for you to complete this. Okay, so I think we can proceed. So what I'm going to show you last is how you extract the clusters. So in k-means, what we were using was this part here. So k-means dot underscore labels. So in hierarchical clustering, so how do we extract the cluster labels? So here we have this part here where we have the f clusters. So this is the function that we use to extract the clusters that we have in this dataset. So these will give our data points labels. And here you see this T3, it determines the number of clusters you are going to have in your dataset. So this T here. And that's the reason as to why I mentioned that when fitting your model, you don't have to specify the number of clusters that you need. So let's do that here in our actual code. So I'm going to extract the labels. So let me see if these works first. So that also works. And what I can confirm is what are the unique groups that we have in this dataset. So we are going to have iris copy dot just a minute. Let me check the unique values that we have here. So we have 1 and 0. So it means that we haven't created that many groups. So I'll extract the labels. So we'll have from sklearn.cluster.hierarchy import fcluster. And then what I'll do here, instead of extracting the labels, so what I'll do is I'll create 4 clusters. So we are going to have our labels being equal to fcluster. Then we pass in our linkage matrix. Then we pass in the number of groups we want. And then we pass in the criterion that we want in here. Okay. And then after doing that, we assign the labels, or we can create a class subplot those labels. So let me reduce it to 3, and then we can compare what we have here in k-means to what we had. So we can compare what we have here in hierarchical clustering and what we had here, what we have here in this. So we have 1, 2, 3, 4, 5, 6. So we have 6 groups. Okay, let me play around with that value. So 6, 9. Okay. So I don't know why this one is set to be backwards, but when I set this number to be 9, it means we have 3 distinct groups. When I set it to be 3, it means we have 6 distinct groups. So I'll have to check why my model is doing that. Because here we've specified our t being equal to 3. You can see here in the notes it's saying, and the maximum number of cluster is set to 3, where t is the parameter, represents the maximum number of clusters. So on my side, I don't know why when I set it to 3, we get 6 clusters, while we should be having only 3 clusters. So I'll investigate that and share that with you guys, the reason as to why we are getting that. In the meantime, we can compare what we have here to what we had in k-means. So this is our hierarchical clustering plot. And up here, we have our k-means plot. So down here, we have our first cluster. We have our second cluster here, and we have our third cluster up here. So the results that we are having for both models seem to be a little bit similar, in that we are getting the same kind of groups and we are getting the same kind of splits from the data. So not unless we have some unique cases. So for example, this data point here and the data point that we have up here. But both the two models are giving us similar results. So when dealing with clustering, you can either use k-means or you can use the hierarchical clustering model. So I'm going to give you 5 minutes to copy this, and let me split my screen. And you can copy this code that is up here, just in case you never completed that. So I'll give you 5 minutes to complete this, and then we can call it a day. And then what I would want you to do is go and apply hierarchical clustering in the project that we did in class and see if you're going to get similar results as to what we got then. So using the wine clustering dataset. So as you are copying this code, I'll stop the recording